So to study motion of objects moving in 2 and 3 dimensions, we need to have some mathematical knowledge, and the mathematical knowledge we need to have is called vectors. So today we are going to see an introduction to vectors. So there are two types of physical quantities. First one is scalar quantities, and second one is vector quantities. So scalar quantities have only magnitude and they don't possess any direction, whereas vectors have magnitude as well as direction. For an example, if we consider the distance covered by an object when it goes from some point A to some point B, then we need not specify the direction. So to tell about the distance, okay, we need not specify direction. So distance covered is a scalar quantity. Similarly, speed is scalar quantity. Then energy. So all these are examples of scalars. So these quantities, distance, speed, energy, they have magnitude only and they don't have any direction. Now, if we talk about displacement of an object, then displacement is a vector quantity because it has magnitude as well as direction. Similarly, velocity, force, all these are vector quantities as they possess magnitude as well as direction. Now vectors are represented by arrows in space. So suppose I want to denote displacement of an object. So displacement is the shortest distance between start point and end point of the motion. So to represent displacement in 2 and 3 dimensions, I will draw an arrow in space. Okay. So the tip of this arrow represents the direction in which displacement has taken place, and the length of this arrow represents the magnitude of the displacement. So for an example, let's suppose some object moves from this point to this point and it may follow any path. So it might go along any path, but what is its displacement? It's the shortest distance between start point and end point. So if object goes from point A to B along any path, then we can say that its displacement is this vector or this arrow drawn from its start point and to the end point. Okay, so this is the displacement. Now the tip of this arrow tells us about the direction of displacement, and length of this arrow tells us about the magnitude of the displacement. So suppose this is S bar. So to represent vectors, we may use some letter. So because it's a displacement vector, we are using letter S, and we are drawing this arrow on top of S to show that it's a vector. Okay. Now let's see some terms related to vectors. So first term is negative of a vector. Now suppose this is any vector A bar. So negative of this vector will be a vector having same magnitude but in opposite direction. Okay, so this is obvious. So if this is A bar, then a vector which is directed opposite to this vector and which has same length is known as negative of this vector. So I can say this vector is minus of a bar. Okay. The next term is 0 vector. Now, if you add or subtract two vectors, what will be the resultant? It must be a vector. Okay. So if I add a bar and minus a bar, what will be the resultant? Resultant will be 0, but because on left hand side we are performing addition or subtraction of two vectors, so their resultant should be also a vector. So here we draw an arrow on top of this 0 to show that it's resultant of addition or subtraction of two vectors, and that's why we call this one a 0 vector. Okay. Then next term is unit vector. So what is unit vector? The meaning is clear from the name itself. It's a vector in a particular direction and it has unit magnitude. Okay. So if we consider, let's say this vector, suppose this is force acting on some body and force is a vector quantity. So we represent it by F bar. So suppose the length of this vector is 3 units. Okay, so magnitude of this force is suppose 3 newtons. Then if I divide it into 3 parts, 3 equal parts, so like this, then a vector in same direction having magnitude equals to 1/3 of this vector is known as unit vector in direction of F bar. Okay. So this vector is unit vector in direction of F bar and it can be represented by F, and we draw a cap on top of that to show that it's a unit vector. So unit vectors are represented by a hat or a cap. Okay. Now I can represent this F bar in terms of this F cap or this unit vector. So now if I want to find out, if I want to represent the magnitude of F bar, so to represent magnitude of a vector, we use a modulus sign. Okay. So if I take modulus of this vector, then that modulus gives me magnitude of the vector. So as I said, magnitude of this force is 3 newtons or 3 units. So modulus of F bar equals to 3. Now how much is magnitude of this F cap? Magnitude of unit vector is 1 unit. Okay. So magnitude of F cap equals to 1 unit. So here it's a force, that's why I can say it is 1 Newton. Now if I want to write F bar in terms of this F cap, then what should I do? So I will write F bar equals to 3 times F cap. Okay, because magnitude of F cap is 1 unit, magnitude of F bar is 3 units, so F bar is 3 times F cap. Or I can equally write it as, since 3 is magnitude of F bar, so I can write it as magnitude of f bar times f cap. So now if I take this magnitude on the other side, then we get definition for unit vector in a particular direction. So what is the definition? We get f cap equals to f bar divided by magnitude of f bar. Okay, so a vector divided by its magnitude gives us unit vector in that direction. So now that we are familiar with some concepts related to vectors, some terms related to vectors, let's see addition of vectors. So let's talk about addition of vectors. So let's suppose an object starts from this position. Okay, so let's call it O, and it goes from this point to some other point, let's say this point. So this is A. Okay, we don't know the path along which it goes. The path can be anything, but we know what is displacement vector for this starting point and this end point. So displacement vector is the line joining start point and end point, and it is directed from start point to the end point. Okay, so suppose our object goes from O to A and it follows any path, let's say like this. Okay, we don't care. Displacement will be a vector directed from O to A. Okay, so let's call this vector P. Okay, so this is my P bar. All right, then suppose the object moves from point A to some other point. So suppose it goes to this point B. So it moves along any path, but it goes from A to B now. So what will be displacement vector? It will be a vector directed from A to B. Okay, so now to show vector I have to draw actually a tip at the end point. Okay, because this length of the vector denotes magnitude of the vector. Okay, so this is suppose displacement vector from O to A, and this one is displacement vector from A to B, and suppose this is Q bar. So what is total displacement of this object which goes from O to A following some path, then it goes from A to B and it follows yet another path? What is total displacement of this object? So for displacement we only care about start point and end point of the motion. So the total displacement will be a straight line starting from the start point O and ending at the end point B. Okay, so a vector directed from O to B and having length equal to OB will be the total displacement. All right, so suppose this is R bar. Now total displacement should be equal to what? Sum of partial displacements. Therefore sum of these two vectors P bar and Q bar should be equal to R bar. All right, so I can say that R bar is equal to P bar plus Q bar. Alright, so now R bar is equal to P bar plus Q bar. This total displacement is equal to sum of these partial displacements. So here we get a rule for addition of two vectors, and rule is like this: if two vectors are represented in magnitude and direction by two sides of a triangle taken in order, means second vector starts at the point where first vector ends. Okay, so when two vectors are represented in magnitude and direction by two sides of a triangle taken in order, then the resultant is represented by the third side of the triangle starting at start point of the first vector and ending at end point of the second vector. Okay, this is triangle law of vectors addition. So let me write, this is known as triangle law of vectors addition. This is addition of two vectors. Now let's see how to subtract two vectors using triangle law. So suppose I have a vector like this. This is my a bar or something, and I have another vector, let's say this is b bar. So what I want to do is I want to subtract this b bar from a bar. Okay, so what should I do? What I will do is I will find out a vector called negative of b bar, okay, minus of b bar. So it's a vector having same length but opposite direction to that of b bar. So this is minus b bar, and then I will add this minus b bar to a bar. Okay, so result will be same as subtracting b bar from a bar. Okay, so I will add this minus b bar. So I will take this minus b bar and put it over here. So let me erase b bar. Okay, so then resultant of addition of a bar, sorry, subtraction of a bar and b bar will be resultant of addition of these two vectors a bar and minus b bar. Okay, so a vector directed from start point of a bar to end point of minus b bar is suppose r bar. So this r bar is equal to a bar plus minus b bar, or we can just say r bar is equal to a bar plus b bar. Okay, so this is subtraction of vectors using triangle law. So now let's talk about the resultant. So let's find the relation between the two vectors that we add and the resultant we get. Okay, and it is known as the parallelogram. So now let's see the parallelogram law of vectors addition. So parallelogram law is nothing but it's a triangle law put in different words. So let's see how. So let's suppose we have two vectors like this. So suppose this is my a bar, this is my b bar, and we know that the resultant is a vector starting at the start point of a bar and which ends at the end point of B bar. So this is resultant of A bar and B bar. So let's suppose this is R bar. Okay, and this rule, because these three vectors make a triangle, so this rule of addition we call it as the triangle law of vectors addition. Now what I can do is I can pick this B bar and I can draw it over here, okay, at the start point of A bar. So I will draw B bar over here. So this is my B bar. Okay, so now if I join this point and this point, then what do I get? I get a parallelogram. Okay, so now A bar and B bar are represented by two sides of a parallelogram starting at the same point. Then what is the resultant? The resultant is a diagonal of the parallelogram which starts at the same point as that of A bar and B bar. Alright, so this rule is known as parallelogram law of vectors addition. If two vectors are represented by two sides of a parallelogram in magnitude and direction, then their resultant is represented by the diagonal of the parallelogram starting at the same point as that of those two vectors. Okay, now what I want to do is I want to find out the magnitude and direction of this resultant in terms of the magnitude and direction of A bar and B bar. Okay, now what we are going to do is we are going to find out the resultant, the magnitude and direction of this resultant R bar. So for that we extend this CD, so we extend this line CD and we draw a perpendicular starting from this point. Okay, so suppose it meets at point M. Alright, so perpendicular drawn on E on this CD extended meets at point M. Now so let's consider this triangle CEM. So in triangle CEM, let's use Pythagoras theorem. So in triangle CEM, let's use Pythagoras theorem. I can say that R square, so R is magnitude of R bar, R square is equal to this side square plus this side square, or I can say C square is equal to CM square plus EM square. So in triangle CEM by Pythagoras theorem, I can say CE square is equal to CM squared plus EM squared. Now if we see over here, the length of this side CE is magnitude of R bar. Okay, so suppose that R is equal to magnitude of R bar. So for simplicity, then A equals to magnitude of A bar I'm sorry, then another vector that we have is B, so B equals to magnitude of B bar. Alright, so let's suppose R equals to magnitude of R bar, A equals to magnitude of A bar and B equals to magnitude of B bar. So here length of this side CE is magnitude of R bar, and that's why I can write it as C square, I can write as R square. So this is equal to CM square plus EM squared. Then over here I can say Cm is equal to Cd plus Dm. Okay. So I have R square equals to Cd plus Dm. Cm is Cd plus Dm, and we have square of that plus Em squared. And after that, let's expand this. So expanding this Cd plus Dm squared, we have Cd squared, okay, length of side Cd square plus 2 times of Cd multiplied by Dm plus Dm squared plus we have Em squared. Okay, so this is our R squared. Now we got this equation. So what is CD? CD is magnitude of this vector A bar. Okay, so it is A. Now we have dm and em. Okay, so we have to represent lengths of these sides dm and em in terms of this other vector b bar. All right, so now suppose this angle is theta. Okay, so in this triangle DME, what will be sine theta and cos theta? I can say sine theta equals to this opposite side divided by hypotenuse, and length of hypotenuse is magnitude of vector b bar, so I can say it is b. Okay, so it is DE divided by opposite side is EM divided by we have DE, so this is our sine theta, opposite side divided by hypotenuse, and cosine theta is adjacent side divided by hypotenuse, so it is dm divided by de. Okay, so it is dm divided by de. So now we can represent em and dm in terms of de, or which is the magnitude of b bar. So let's pick this up from here. So we have this relation, we have these relations, and therefore using these relations I can say that I can write Em equals to dE multiplied by sine theta. Okay, if I take this dE on other side, I can say that Em equals to dE multiplied by sine theta, and dm equals to dE multiplied by cos of theta. So dm equals to dE multiplied by cos of theta. Now let's substitute it in this equation. Okay, so substituting, we get r squared equals to cd squared plus 2 times of cd multiplied by dm. We found it is d multiplied by cosine theta, so it is d into cosine theta plus dm squared, which is d cos of theta square, and then we have em squared, which is d sine theta squared. Okay, so we have de sine theta squared. So what is CD? CD is magnitude of vector A, DE is magnitude of vector B. Okay, so let's write CD and DE in terms of magnitudes of vectors A bar and B bar. Okay, that's A and B. So CD is magnitude of vector A, that is A. So we have A squared plus 2 times of A multiplied by DE is magnitude of vector B. So 2 times of A into B multiplied by cosine theta, plus we have d cosine theta squared. So d is vector B, sorry, magnitude of vector B. So we have b cos theta squared plus we have d sine theta squared. So it is b sine theta squared. Okay, so this can be written as a squared plus 2 times of a into b into cos theta plus b cos theta squared can be written as b squared cos theta squared is cos square theta, plus we have b squared sine square theta, okay, which is this term. Then we can take b square common from these two terms, so we are left with cos square theta plus sine square theta, and that's equal to 1. Okay, so we have a squared plus 2 times a multiplied by b multiplied by cosine theta plus b squared cos square theta plus sine square theta, and cos square theta plus sine square theta is 1. So we can say that r squared equals to a squared plus b squared plus 2 times a into b into cos of theta, and therefore r will be equal to square root of a square plus b square plus 2 times a into b into cos of theta. Okay, so here we have represented the magnitude of resultant in terms of magnitudes of the two vectors which we are adding to get that resultant. And what is theta? So if we go back and see, theta is this angle. Okay, so since this angle is theta, I can say that this angle is also theta. Alright, these are two parallel lines and this is an intercept. Okay, so this angle and this angle will be identical. So this angle is also theta, and what is this angle? It is angle between a bar and b bar. Okay, so what we got is the formula for magnitude of the resultant in terms of magnitudes of the two vectors that we are adding and the angle between those two vectors. All right. So this is magnitude of the resultant, and it's very simple to memorize it. So magnitude of the resultant of addition of two vectors is square root of magnitude of first vector squared plus magnitude of second vector squared plus 2 times magnitude of first vector multiplied by magnitude of second vector multiplied by cosine of the angle between two vectors. Okay, so now what I want to do is I want to find out direction of this resultant also. Okay, so how do we find direction of some vector? Now this is a vector on a plane. So if we know angle made by this vector with one of these two vectors a bar and b bar, okay, if we know the angle made by r bar with one of the vectors either a bar or b bar, then we can say that we know the direction of r bar. So let's suppose the angle between a bar and r bar is alpha. Okay, so if we are able to find out this alpha given a bar, b bar and angle between a bar and b bar, then we can say that we have found direction of r bar. So let's find out alpha. So now in physics this is general convention that in order to find out an angle we use tan of an angle. Okay, so if I consider this triangle, in triangle CDE now, sorry, in triangle CME, what will be tan of alpha? Tan of alpha will be equal to this opposite side EM divided by the adjacent side, so EM divided by CM. Okay, so tan of alpha is EM divided by CM, and then I can write CM is equal to CD plus DM as before. So I get EM divided by CD plus DM. And then we have already found what is EM, then what is DM, etc. and what CD we know. So CD is the magnitude of vector a bar or it's a. Okay, EM and DM we already found in terms of vector b bar. So EM is this vector, sorry, it is d multiplied by sine of theta. DM is d multiplied by cos of theta, and de is magnitude of vector b bar. So let's write it like that. So we get tan of alpha equals to EM. So EM is d sine theta. Then CD is magnitude of a bar, so it is a, plus this is d cos of theta. And what is de? It is magnitude of vector b bar. So we can say this is equal to b sine theta divided by a plus b cos of theta. Okay, since length of side d is equal to magnitude of b bar. So this is my tan alpha. So what will be alpha? So alpha will be equal to tan inverse of this thing. Okay, tan inverse of this thing in the bracket. So it is tan inverse of b sine theta divided by a plus b multiplied by cos of theta. Alright, so we got the angle alpha. That means we can say that we got direction of r bar in terms of magnitudes and direction of a bar and b bar. Okay, so here we have tan inverse of alpha equals to tan inverse of b into sine theta divided by a plus b cos of theta. So a and b are magnitudes of a bar and b bar, and theta is the angle between them. So this is our initial information that we have two vectors a bar and b bar. A and B are their magnitudes and angle between them is theta. So given that initial information, we found the magnitude and direction of resultant vector r bar. Okay.